Hey people who are gone, this is 4-3.
Hi.
The first part of this, part one, the probability of at least one. This is a really hard concept to understand, so you really have to focus for the next, 5 minutes, okay? At least one. Sit down and be quiet, I'm recording. Okay, probability, at least one. Anytime on a homework assignment they say, find the probability of at least one, you're gonna go, because it's awful, okay? But I'm going to show you how to cheat and make it easier, okay? So you ready for this? All right.
Cheating is not good.
At least one. At least one. We're going to talk about, let's write down the combinations of 3 babies. Okay, write this down off to the side. 3 babies, okay? There are how many combinations of genders of 3 babies?
8.
8. So let's list them. I could have a boy, boy, boy. Okay, I could have a boy, boy, girl. I could have a boy, girl, boy, or a boy, girl, girl. List these down. Okay, that's 4 of them. The next list, let's do girl, boy, boy. We'll go the opposite, right? Girl, boy, girl, 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 boy, or girl, girl, girl. I'm doing everything like the opposite, okay? So there's 8 of them, okay? There is 8 of them, yeah?
Yes.
Okay, I'm going to show you how this makes it easier.
And 4 girls, yeah.
Let's say that I am interested in finding the probability of at least 1 girl, okay? The probability of me having 3 babies and getting at least 1 girl. And you see that at least and you're going to go, at least 1, okay? Because there's a lot of combinations that could be at least 1 girl. Like, for example, this is at least 1 girl. This is at least 1 girl. At least 1 girl, 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 right?
So 7.
Okay? So 7 out of 8. Now, I don't want to. Here's what I don't want to have to do. I don't want to have to make the dang list every single time, because let's say they say a combination of 4 babies. Do you know how many combinations there are with 4 babies?
Too many.
2 times 2 times 2 times 2, which is 16. Do you want to list out all 16 combinations?
No.
Probably not, right? So here's how you cheat. Are you ready?
Yeah.
Okay. 7 out of 8 gives me at least 1 girl. What I'm going to do is something called the complement, okay? Complement, okay? The complement equals the opposites, okay? So the opposite of getting at least 1 girl is the probability of getting no girls, correct? Okay? Now, I can easily figure out that there's only one combination that will give me no girls, right? There's only one combination, and it is boy, boy, boy out of a total of 8, right? Only 1 out of 8 will give me no girls, correct? So then I'm just going to do the opposite, and I know that that's 7 out of 8, right? And I don't have to do the whole list of things, correct? Okay?
Correct.
So when they're asking you for at least 1, you do the opposite and you say, okay, I don't want any of them. Now I'm going to subtract that and find the other probability, okay? So let's go up here and let's say I have 4 babies, right? We know there's 16 combinations. And I say the probability of at least 1 girl, okay? At least 1 girl. Now you know the rule, right? How many combinations out of those 16 won't get me at least 1 girl? 1 out of 16, so how many will give me at least 1 girl? 15 out of 16. Do you see how that works?
Yeah.
We do the opposite and then we subtract, right? Okay, so at least 1 is not terribly difficult if you do the opposite, right? But at least 1, if you don't know how to do the trick and do the opposite, you have to list them all out, and nobody wants to do that, right? I don't want to list out all 16 combinations because I'm going to miss one, right? So 15 out of 16 would be that combination, correct? Okay, that is something like at least 1 has the same meaning as 1 or more, and it says do the complement of at least 1, which is getting none of that. No occurrences of that event. So no girls and then subtracting, okay? All right, now complements. I know we've talked about this before. Shh, be quiet. Shh. Complements. If I'm saying event A is what I want, the probability of A, the complement is noted as A bar. A bar. So at least 1 girl, if that's event A bar would be no girls, correct? Those are opposite from each other, okay? All right, and then you subtract from 1 to get those percentages, they add up to be 100%, correct? Okay, here we go. So example 1, they're giving us information other than the boy-girl stuff. Here we go. Shh. Put it down. A study by Square Trade found that 6% of damaged iPads were damaged by bags or backpacks. Okay? So like they put it in their bag. Now,
Like
how else could it be damaged?
Maya could throw it
Anyway.
Dropping it, throwing it,
Spilling a drink on it.
spilling a drink on it. Okay,
Stepping on
so
it.
6% are damaged by bags and backpacks, like it
Yeah.
being dropped in your backpack. Otherwise, 94% of the time it's damaged other ways, okay? Alright, here we go. Here you go. If 20 damaged iPads are randomly selected, this is going to be confusing, you gotta listen. Shh, quit. Put it down. I'm not gonna ask you again. Shush. 20 damaged iPads are randomly selected. Find the probability of getting at least one that was damaged by a backpack. If I have 20 damaged backpacks, or damaged iPads, I could have this scenario, don't write this down. I could list out all 20 of them, and I could say yes damage, no damage, no damage, no damage, no like I have like a huge list of like way more than 20 combinations where like some of them are damaged by a backpack and some of them are not damaged by a backpack, okay? So where it says at least one, I could have one damaged by a backpack, I could have two damaged by a backpack, three damaged by a backpack, that's at least one. All of those combinations are at least one. So what I'm going to do is I'm going to do the probability that none were damaged by a backpack. No, I'm going to say BP damage, okay? Damage, there we go. No BP damage, no backpack damage, okay? The probability of at least one being damaged by a backpack, the opposite of that is the probability of none of them being damaged by a backpack, okay? So, none of them damaged by a backpack means the first one was not damaged by a backpack. What's the chances that the first one was not damaged by a backpack? 0.94. 6% were damaged by backpacks. 0.94. What's the second? What's the chances that the second one was not damaged by a backpack? 0.94. The third one not damaged by a backpack. 0.94. How many times do I have to do this? 20 times. Okay. I don't want to do that. I want to do instead 0.94. Not times 20, to the 20th power. 0.94 to the 20th power. 0.94 to the 20th power. Somebody do that real quick on your calculator. Take it. You should have like a caret button in your calculator or something like that.
Bro, what carrots do you eat? That ain't no carrot.
That's what they call it, is a caret. Anyway.
Actually, can't do that on my phone.
0.2901. So 29% chance that none of them were damaged by a backpack. So, what is the chances that at least one?
The opposite of that.
29%.
No, the opposite.
No.
27.
Probability that none were damaged by a backpack is 0.29.
70.
So this is the
71%.
opposite of this. So 0.7099.
So 71%.
71% basically. Does that make sense? Do the probability of none, which is those multiplied together 20 times. Good? And then subtract.
Yeah, we good.
Yeah? Yeah?
We good. Are we gonna finish this?
Good?
Yeah, that's it.
I think we should.
I kind of want to do another example
I have
though.
a
Like
question
not
when we're done.
the next example, but like doing another one.
One more.
No,
is
it's fine. We get it.
Let's do one more. What?
I have a question when we're done
Okay. Okay.
about something else.
Do another example over here. Put this off to the side and then maybe we'll be done. And then I'll let you work on stuff. Okay? Example. The probability of my tree or plant. We'll say plant.
Is this the
The
tree that
probability
your
of my
brother
plant
planted?
dying. No.
No? Not the tree that your brother planted. I think it should be.
Okay, the probability of my plant dying, let's say, is 20%. There is a 20% chance that my plant is going to die. It should actually be like 99%, but whatever, we'll go to 20%. We'll give me a little bit more credit. The probability that my plant dies is 20%. I want you to find the probability. Okay, let's say if 10 plants, find the probability at least one dies. Okay, if I have 10 plants, find the probability that at least one of them dies. Alright, rather than doing probability of at least one dying, we're going to do probability of
None die.
no die.
0.8.
Alright, hold on just a second. How do I do probability of no dying? The first one doesn't die. Okay? Now, hold on a second. Hold on a second. Hold on a second. Hold on a second. What's the probability that the first one does not die?
$7.
8.8.
0.8.
To the 10.
Hold on. 0.8. You have to subtract those. Gracie and Clayton, you gotta listen.
Wait, how?
Okay? Because we're talking about dying. 20% is my death rate, which means
Oh,
if
so
I'm
you
talking
can't
about
do-
not
yeah,
dying,
yeah.
it would have to be 0.8. Okay? The second one not dying would also be 0.8. How many times do I do that?
0.8 times to the 10th power.
0.8 to the 10th power, which is what?
10.7%.
10.7%. Okay? So 0.107.
Yeah.
Okay? That is the probability of none of them dying. What's the chances that at least one of them is going to die?
89.3.
0.893 or 89.3%. Do you see how this works?
Yeah.
I see how
Do
that
the
works.
opposites. Do the opposites and subtract. 0.8 because we go from talking about dying to talking about no dying. So if 20% are going to die, 80% are not going to die. We do the opposite. Kind of like 0.6 and 94%, right? Okay? So you do that. There you go. Okay?
Hey,
I don't
This
understand.
gets a little confusing.
why don't we just put this recording on Classroom for me?
Sure.
Can I have a help?
Or I'll just email it to you when I email.
I need it too because I was
Why?
writing fire stuff.
Okay, whatever. Okay, there. That's all the farther we're going to get. Start on your homework because some of these are tricky.